8C6. Here we go. Okay, here we go. Grades are updated. If you have yet to turn something in that's late, please do so by next Monday. Would be great. We're on week 8. We're going to be covering authentication tonight. On Thursday, we'll be doing a lab on PGP. If you would do this, do me a favor between now and Thursday. If you don't have a Gmail account, you will need a Gmail account for Thursday's lab. Set up a free Gmail account if you don't already have one, or if you want to set one up separately just for this lab. This is a zip file that actually will run off of a USB thumb drive, and it's called Thunderbird, which is a full email client, and we'll be using PGP to encrypt and decrypt emails. You'll set up a trust between you and a neighbor in the class and send and receive encrypted emails using PGP, okay, which stands for Pretty Good Privacy, and we'll go over that a little bit tonight and also on Thursday. This document you can actually read if you want to ahead of time also, because we'll be covering that as well on Thursday. Okay, let's go ahead and get started. We're going to cover tonight authentication. Yes?
On the Gmail account?
Yeah?
You can't use RBC?
No, can't use the RBC. Has to be separate. Separate from the RBC.
The RBC?
Your RBC Gmail? Yeah, has to be separate from that. Yep. Because we'll have to go in and play around with the settings, and so you have to create your own free email account to do that. Okay, this chapter talks about authentication and different types. We're going to go through, I believe, 36, 37 slides here, so yeah, slow down. Then, authentication. How many logs in throughout the day at one or more login prompts, username, password, throughout the day? One or more, okay? So everybody in here, you use authentication. You might not know how it works, but you know you use it. And this week we're going to be dealing with authentication and also encryption, which fits well with authentication. But basically, whenever we talk about authentication, there's two types of context you need to realize. One is viewing authentication as it relates to access control, meaning when you log into a VPN connection, possibly from home to work or on the road to work, you might have certain access controls to your workplace, certain folders you can get to, certain programs you can run. Second way to look at it is one of the three key elements of security, which would mean authentication, authorization, and accounting of that authentication piece within a network. And every network is going to have some type of authentication built in. It might be open, but it's still authentication. So access control is one of the main reasons to utilize authentication, because when you're accessing whatever resources, you want to be able to control as an admin what people get to see, what time frames, what they get to write, edit, delete, move, whole bunch of different scenarios you can think of. But access control is a process by which resources or services are granted or denied. As a network admin, you'll be setting up access control to end users as they log into your network, on what rights they have, what maps are derived possibly on their local computer from the network. Here are the points underneath that. One is identification first. When you guys logged in today, multiple places, which I saw raise the hands, you presented a server somewhere with credentials of yourself, username and password. Authentication is the next one, which is verification that you are who you say you are. Currently, most of you only use username, password, I'm guessing, okay? We're going to look at the device tonight in just a second that would add another piece to it, which would be biometrics. Next is authorization. Once you've been identified, you've been authenticated, now you're authorized to grant you information and data into the doorway of the network. And then finally, access is the right to use specific resources. So AAA, which is the process of authorization by identifying a user, typically having them enter in a valid password, username combination. Authorization is just a process of determining whether the user has authority to carry out some task, often some type of enforcing policies. Those policies could be time frame, it could be rules like what resources they can have access to and don't have access to. And then accounting measures are resources a user consumes during network session. You can actually limit within a session downloading bandwidth. You can also limit within a session time that they're allotted. Has anybody logged into possibly, I don't know, a public kiosk where you only have a certain amount of time to play with something and then it kicks you off? Or you go to Kinko's and you pay for a certain amount of time and then it kicks you off. Be another example. So you can actually account for network resources and limit it by a whole bunch of different criteria. So the information that can be used can be how to find evidence of problems, billing, planning, and you might not have thought about this, but the first one, evidence of problems, if you have authentication in place on a network, you can determine through log files failed login attempts at certain stations, certain times of day, certain time of the day, where you can set up a camera possibly on that station, which I've done multiple times, to determine what's going on. In the past, it's been maybe a maintenance person was trying to log into a computer when they shouldn't have been. Maybe a person was trying to go into their boss's desk and log in for access, or I've seen in HR where folks have tried to go into HR and log in to get access to personnel file. So a whole bunch of different reasons you could think of why people do it. But evidence is one of the reasons, because the log fail attempts, you can't have a log unless you have a rule in place first for authentication. Then billing, you can actually set up, if it's a downloadable thing that you're keeping track of, marketing has downloaded X amount of files, they've been online for X amount of time, and this is going to be the cost for that department. Seen companies do it that way. And then planning, you can plan on changes and maybe needed security that you currently don't have through authorization and accountability. So AAA servers, basically servers that are dedicated to performing these functions, authentication, authorization, and accounting. Windows Server, since the beginning, has been able to do this. Linux, Mac OS X, just to name 3 of them. They can provide significant advantages on a network, setting up authentication. So types of authentication, we've talked to some of these already this semester, but passwords, which everybody uses in here, one-time single sign-on, standard biometrics, which I'll pass this around. We actually do a lab using this in a few weeks, but I'll go ahead and show it to you. It's a simple biometrics device for fingerprint authentication I use a lot. Behavioral biometrics. Standard biometrics, let's talk about that for a second. We're going to go deeper in a second, but standard basically is fingerprint, which is the #1 way to authenticate using biometrics. Retina, voice, facial are the other type, but fingerprint, the one I'm passing around, is the most popular and the cheapest, and probably the less false positives on a fingerprint than any other. Because voice recognition, if you have a cold, some of your voices go higher or lower, depending on your health. Also, facial, you grow a beard or a mustache, or you gain weight or lose weight, it can cause your face to change, and that could be a lot of false positives. And then retina does have low false positive, but very expensive to implement, very high cost. And then behavioral biometrics and cognitive biometrics has to do with different components of how you set up that biometric. And be on behavioral, could be a number of different components we'll look at in a second, and also with cognitive, a number of different components. So let's talk about, first of all, the one-time password. This is just a dynamic password that's changed frequently. Systems using a one-time password generally generate a unique password on demand that's not reusable. The most common type is a time synchronized one-time password in conjunction with a token of some type. And the token and corresponding authentication server share the same algorithm. Each algorithm is different for every user that logs into the system. Here's an example of a one-time password every time, and it could be in a hardware device coupled with a software device for authentication. So you've got a user here that logs in, enters a one-time password. L. Burris is their username, 598475. It takes that information, plugs it into an algorithm token, pushes it to Authentication Server, and you'll notice every user has a unique one-time password given to them through this device. These can actually be USB devices plugged into a laptop, mobile device that actually generates the password uniquely each time. One time and one time only, one time session only. Now this device you guys just passed around, this is like 2 or 3 years old, 2.5 years old, I think it is. We actually do a lab where we set it up on this computer here, and you guys go in and set up a user for everybody in here. And we discuss the security ramifications of this. They do have new ones out, by the way, that are basically, this one's, like I said, an older one, but the newer ones actually have, they can determine if you have a pulse and blood flowing in your fingers, so it can't be faked out with a glove or some type of prosthetic device. Yeah, and they're actually not much more expensive than what I paid for this 2.5 years ago. So it really gotten reasonable. Now, one-time password, several variations. You've got a authentication server basically that again has a random number that the user is given each time that they log in. The user then enters some type of challenge number, kicks it back to Authentication Server, and then they're let in. Now, normally on these OTPs with the device-driven ones, the user doesn't really do anything but plug it into their system, go into a certain URL on the computer or a certain program, and the OTP kicks in automatically. But they have to have that device plugged in to the computer, to the laptop, in order for this to work. Next is standard biometrics, one I just passed around. This uses your personal characteristics, which everybody has unique fingerprints, iris, hand, face, retina. Now there are some issues we'll talk about when we do the lab. Some people don't have readable fingerprints by birth, a very small percentage, but it's there. That's why you don't see it as widespread as you think you might for fingerprint biometrics. Types of fingerprint scanners: static one or dynamic. This one here is a static one. Generally on a static one, you probably set 2 or 3 registered fingerprints. That way if one of them gets bandaged or something like that, you have another one to authenticate with. Disadvantage, and it's really not disadvantage anymore, cost. This one definitely, reader's not always foolproof. You'll see that when you do the lab. There might be some of you have to do it twice to take it. You might have seen these on laptops possibly, already built in to the hardware. You just swipe your finger over it and it logs you in. Now, behavioral biometrics are authentication by normal actions that the user performs, and they have what's called Keystroke Dynamics. It attempts to recognize the user's unique typing rhythm. Keystroke Dynamics uses two unique typing variables, dwell time and flight time. There's actually technology out there now that you can, that doesn't have to do with logging in, but it has to do with, say a user hacked into your computer or got your password and got in, software running in the background that determines it's not you in about 2 or 3 minutes after typing on the keyboard. Because everybody in here has a unique pattern of how you type. Everybody. And normally it's 99% foolproof on authenticating. And what it does is it locks out that person that might be in there that's not you, and it can do a number of things: alert a system admin, lock doors where the person can't get out. A number of things you could do if you could be creative in your thinking. So Keystroke Dynamics is one way biometrics is used. The other is, you'll notice here, a user has a password. Okay, pretty easy to find that out. But then they come in and they begin typing in their password, and even the recognition of the password as you type it in and how you type it in and the speed of how you type it in can be determined by this type of biometrics. So even if you type in the correct username and password, it won't let you in because you didn't type it in the way the original user types it in the speed they type it in. Because all of us type in, certain characters we hit faster than others, and it's just habit. Okay? There might be some characters, if you're like me on the keyboard, that you're always having to remember where they're at for some reason, even though you worked on the keyboard for 30 years. You just, for some reason, and so that little lag time falls into this play. And the way they train it in the biometrics in this category is they have you type in certain sentences, static sentences. Everybody uses the same sentences to set it up, and then they determine your pattern from that. And then it's locked in. So a user, again, types in their username password. The actual approved user, that's the user that's the valid one, is let in. The attacker is not let in. Now this is probably one that most users haven't heard of, which is a behavioral biometrics. Most of you have heard of fingerprint, retina, facial, voice, but probably behavioral you didn't know much about. It's not been out real long. It's really peaked in the last couple years. You'll probably see more of it on the shelf and built into laptops and portable devices. Next is voice recognition. Uses your voice based on the unique characteristics of your voice. You have some type of cadence, all of us do. Cadence, you might think of a cadence as the speed. It is the speed of your voice. Pitch, speaking two words together in a way that one word bleeds into the next, becomes part of your cadence, and it can be tracked and traced and recorded. And then computer footprint, when and from where a user normally accesses. A lot of banks do this now. So if you log in with your laptop usually to your bank, and then you maybe tonight go home and before you go to the car, you take your mobile phone and log in, and it says, the bank goes, first time you've logged in with this device before. I need some more information here. So it's either a code, another password, a picture, something, and then usually it asks you, are you going to log into this again in the future? Or is it just a one-time at a hotel, wherever, airport? And so that's a newer one also that's actually been implemented in the last couple of years heavily, specifically with banks. And then cognitive, this is related to perception, thought process, and understanding the user. Bill Gates actually began using this with some devices that he's developed. It's considered to be much easier for the user to remember because it's based upon your life experiences. One example of cognitive biometrics is based on life experience that the user remembers. Another example of cognitive biometrics requires the user to identify specific faces, or in the banking sense, specific pictures. They have you select, a list of pictures. a dog, a cat, a box, or something. Okay, and you have to select those three each time if you go in and change computers or whatever the case may be. They might periodically do it every 2 or 3 months. So here's a cognitive biometric on this website on online banking. It says here what type of food: meat and potatoes, Greek, Italian, vegetarian, American, assorted, Asian, barbecue, and Indian. Answer each question that appears. Select the answers from the choices offered. And so I'm guessing most of you have had to do this with your bank. How many's had to do this with your bank when you set up online services? Okay, it's pretty common now to deploy the cognitive biometrics. Now, the next is authentication, different models that are implemented. One is single and multi-factor. The one-factor authentication uses only one authentication credential. The two-factor would be 2 different types. Three-factor would be 3 different types. So let's talk about the 2 one. One's fairly easy. The 2 would be you log in with a username password and possibly a cognitive. You log in with a username password and then possibly a biometric fingerprint device. So 2 or more authentication types are the most secure. Generally, one of them has to do with your person, your knowledge, your patterns, whatever you want to call it. Okay? And those are very hard to, or near impossible to hack. Okay? Easy to lift a fingerprint, very hard to lift a cognitive cadence of somebody's speech and typing pattern. That's pretty near impossible. Not that it is impossible, but a little harder to mask and to duplicate. So, a lot of governmental facilities have always had the 2-factor authentication. Voice, hand, print possibly going into a door. They're now adding a 3rd, which is the new behavioral biometrics or cognitive biometrics. They can actually do a behavioral by the cadence of their walk up to the door. They can determine the cadence of the walk to determine if they have access to even go any further. And you know, they're taught this when they log in, or when they're taught the security of the building, so it's not by surprise, so they don't run up to the door. And so everybody has a certain walk cadence as well. And so if, for instance, you hurt your leg, they have fail-safes for other types of authentication if that one's not working correctly or something. So you got a cast or something. So a lot of governmental facilities, high security areas are doing the 3 authentication, which is a combination of different authentications. It can be everything from username password to just cognitive, some type of possibly physical biometrics like a fingerprint or retina scan. Retina scans are fairly, even if you're sick or change hair color or gain weight, lose weight, fairly static on retina verification. Single sign-in, this is actually one that's pretty popular. We have it here on campus in IT and a number of admin areas, and there's actually software Microsoft puts out for single sign-in. And what it is you set it up and train it one time, takes an hour or 2 depending on how many accounts you have, and then you sign in one time in the morning and you have access to all other accounts that you would ever use throughout the day. So that helps with not only productivity, which that's the main reason managers like it, but also when you're talking security, it stops from over the shoulder, people forgetting the passwords, the list goes on and on. And when passwords are changed on all systems, they're set up to where they're changed one time. And then the single sign-on prompts the user and say 30 days, change the password, it changes them all their 20 accounts or whatever. So pretty cool. And it's been out for a couple of years, and it's actually getting more popular too as time goes on, because people aren't getting less and less accounts each year. They're getting more and more accounts that are using, from email to a lot of applications businesses use are online. Next one you might have heard of is Windows Live. Windows You use for a number of things you might not realize. when you install Office. Windows Live is one of the first prompts given to you now to set up a Windows Live account. And it gives you what's called a .NET Passport, which once you set it up, you can then download free trials, you know, all the Microsoft stuff. But one of the cool things it lets you do now is you get free web space, like 2 or 3 gigs of free web space. I think they might have bumped it up to 5 now, some areas, some locations, some apps. So say you had Office and you wanted to share a document with your colleagues, you can use your Windows Live password, username, password, and begin to activate services. And basically it just requires to set up a username and password. When the user logs into the website, they give a Windows Live ID, redirected to Authentication Server. Then that authenticated information is time limited and attached to a cookie on the local computer, and it dies in, say, like 24 hours or whatever the time is Windows Live has out there. So it's a pretty cool service. It's been out for a while. This one is not much used and really hasn't been implemented much, but there's another one called Card Space in Windows. It's a feature that's intended to provide users with control over digital identities and manage your privacy. You've got managed cards and personal cards. And again, most users aren't aware of this. I've never used it. They've not really developed it much, but it is out there, and they're still playing with it. It's kind of R&D. So here's a screenshot of the Windows Live. Anybody seen that before on your computer before? Well, if you've installed Office, you've seen it, because that's the first prompt it has you do is set up a Windows Live account. So you set it up. You can use for the Windows Live account any email to set it up, like Gmail or Yahoo or your Rock Valley email. Once you set it up, then you're authenticated to use the services. OpenID, this is the next one. OpenID is actually an open source authentication device software that's installed on your desktop. It's URL based. And an OpenID identity is only a URL backed up by username and password. And OpenID provides a means to provide the user's own specific URL. And you can use OpenID for such things like web services, websites. So if you need authenticated error on your website, you can download OpenID. It's an open source application onto a web server and use it to authenticate. Macintosh uses it a lot. Mac servers use it a lot. It's built into the Mac. Then next is Authentication Server, which is the end here of everything we've talked about. Some type of server on your network that's going to authenticate. In Windows environment, you're going to have the Windows Server, Active Directory, which we host classes here on campus for that, so I definitely recommend you taking. Basically on this one, you've got different types of authentication servers, Radius, Kerberos. That OpenID uses Kerberos, it's not Kerberos, Kerberos authentication. Taxis, generic server, and then LDAP. You might have heard of LDAP before. LDAP's also an open source authentication that's used in everything from when you log into, let's say, how many use online services here? You've got online services? It uses LDAP to log in. Radius, been around since 92. On this one, it quickly developed and spread like wildfire because it's very suitable for very high volume services. And the reason it came out is big in 92, 93. That's when web services began to get really big. Companies like Sears, JCPenney began to host applications for their employees on the computer that was pushed from the server. And they needed something robust and that would handle the backbone, handle all their services throughout the US. And Radius servers actually fit the bill for them, still around today. It has port security, both wired and wireless port security. And anybody worked at retail, anything before? If you've worked at anything in retail on a POS system, a point of sale screen, most of that software that you work on is pushed from a Radius server. Most of it is. And they're generally, you know, they're not real user friendly, most of those POS systems that in retail, but they work and they're secure, and the employees aren't going to be able to plug in their USBs and download programs because it's a pushed app and you can only do what the pushed app lets you do, and that's it. And so one of the things that Radius is used for is that, pushing applications. And you might have heard of the term thin clients, possibly. Thin clients is actually, here's a server that has all the applications that my business uses, and you guys are all thin clients, and I push out to you from this, this is called be a fat client, to a thin client, which would be you, all of the screens, operating system, programs, and all you really need on your end is a monitor, keyboard, mouse, and a little box to hook all that in, and then everything else is pushed to this. And so Windows, you can set up, fat client to thin client easily. Linux, you can do the same. Macintosh, you can do the same. And then there's a free open source one if you ever want to play with it, called Knoppix. I might have mentioned that in here before, but it's a Linux-based download. It's about, fills up a whole, I think they have a DVD version now. It's like about 3 gigs. Anyway, Knoppix has a service in it called Knoppix Live. Knoppix Live, when you fire it up after you booted it from the DVD, starts a thin client service. And all you have to do on the client end is it gives you a file that you put on a USB drive, and you go around all the computers, you put this file on the computers, executable file or batch file, I think it's a batch file, connects to the Knoppix server, and then you have a full OS with all the applications that you want. I played around with it when it first came out. It's actually streamlined better now. I set it up in a high school classroom, about 30 clients. And what's cool about it is you can set up the Knoppix DVD like you want it to be, meaning you can tailor the apps the way you want them to be. You can put in there presentations, whatever you want to. That way when you come into a classroom or that you're doing a presentation, you can fire up Knoppix on your presentation computer and then just go around with the USB drive and get the thin clients going on all the ones in the room. And they're going to have everything you want them to have, all the applications, demos, forms, whatever it is you want them to have. And what's great about it is, I mean, it's a little bit of a learning curve, but what's great about it is it's free, it doesn't cost anything. And one of the things you'll find out with Linux is there's a lot of free stuff, but there's also a lot of learning stuff that you have to learn how to implement it. But this new one they've come up with, Knoppix, if you Google it, is really slick. A guy from Germany developed it. He's a network administrator, actually developed this Knoppix Linux operating system. Pretty cool, check it out. Lastly here, on Radius, basically, like I said, it can work with hardwire, wireless, and it's responsible on the access point for sending user credentials and connection parameters to and from the Radius server. The Radius server has what's called a wrapper around the authentication. So your username and password has a wrapper. This wrapper is actually encrypted, and it's also password protected, and it usually has some type of key, private key, that's tied to it to where very difficult to hack into, even on a wireless. Radius wireless is a little harder to set up. Cisco has some Radius devices on their access points that actually I've not played with them. The newer ones that they said is pretty simple to set up. But basically, just all you need to know about Radius really is that it has an authentication client and server that talks to each other, has a wrapper around it that wraps that username, password authentication, and it's encrypted. And we'll end on this slide here with the Radius. You've got your laptop, right? Everybody has one of those, or you have a desktop possibly at home that's on wireless, or a mobile device. Here's your username, Susan, password 1chat9, authentication request, kicks out to the Radius server, compares it with the users in the database, acknowledges whether that user and password exist, then it goes over here and records it in the accounting database that they're in. They've logged in at this time, at this station, this MAC address, this IP address, and then approved to connect. So there's authentication, there's management, time management, security management. So this whole piece, Radius server, is set up for wireless access points, wired as well. And Cisco does have a number of Radius devices out of the box that these access points work well with, okay? In fact, if you buy a new Linksys router, wireless router from Cisco, has a button on the front of it, and it's called Connect. You just press it, and then it tells you to turn on your laptop or whatever that has an access point, and it sets up a trust. This is what it's using right now. It's a small, dumbed-down version of Radius. You probably never used it, most of you maybe, but you might, if you've bought a newer access point in the last year and a half, you saw a little button that tells you to hit it to set up, and you might have done it, and you have to follow some steps, but it sets it up a real secure wireless N, and it's used WPA2 Enterprise or Personal, either one. So it sets up real good, real easy to use. Once it's set up, very secure. Okay, on Thursday, PGP, what do you need to get before Thursday? Gmail, not your Rock Valley Gmail, brand new Gmail account, or if you already have an existing one, you can use that one outside, if it's outside of Rock Valley. Trying to think of what else. Oh, USB drive. I've never asked you to bring one in, but if you have a USB drive, thumb drive, bring it in on Thursday, because this app we'll be using, this portable Thunderbird, can run right from your USB drive, and you can take all the setups we do here in class and just take it with you. That way you don't have to leave it on the computer, you don't have to reconfigure it later. Okay, because once you set up your email account on this, you can actually use it on any computer and just plug it in, and you have your email set up right there, both encrypted or just general email. Okay? All right, we're done. Good job. See you Thursday. And if you have any late work, please get it in by next Monday.